Hi everyone, this is Afaq. So my topics are amines and amides. So let's start. Amines, an ammonia molecule in which one or more H atoms are substituted by alkyl or aromatic compounds. So typically we have three types of amines, primary, secondary or tertiary, according to the replacement of H atoms by any alkyl or aromatic compounds. So let's talk about the naming system. So amines can be named in two ways, like the first one is the IUPAC naming system, or the second one is the alkyl derivative of ammonia. So let's talk about IUPAC naming system here. So here we have some examples. So according to IUPAC naming system, we have to consider each molecule as an alkane. The NH2 group is called amino group. Thus the structure in figure A is a butane with amino group on carbon atom 1. So this will be named as 1 amino butane. And in the example B here, uh, there's a hexane with an amino group on carbon atom number 3, so it is called 3 amino hexane, and these both are one node amines. So because they are only connected to one chain here and two H atoms, so they are called primary amines. So let's move towards the secondary or tertiary amines. So for this, the naming the IUPAC names for two node or three node amines include the N prefix to denote the substituted groups on the N atom of the amino group. So like here we have examples C and D. So here in the first one, the methyl group is directly attached to the N atom, and N atom also attached to this longest chain called butane. So we have to write N first, then the name of the alkyl group and position number, and then we have to write amino and the longest chain name butane. So this will be called two node amine, and the second example is an third node amine or tertiary amine. So same in the first example, like here we have three uh, methyl groups on directly attached to the nitrogen, but we have to consider one longest chain like here, and the other two will be uh, treated as substituted groups. So we have to write NN for two groups and dimethyl amine for the N, and at the last methane, because these are this chain will be called methane, one carbon atom. Okay, so here I include some extra examples on the naming system of amines. So if you guys are interested, you can uh, stop the video and look at these. So let's move towards physical properties of amines. Okay, so physical properties, mainly we have lower aliphatic amines are gaseous in nature. Primary amines with 3 or 4 carbon atoms are liquid at room temperature. Lower aliphatic amines can form hydrogen bonds with water, and tertiary amines, there's no intermolecular association due to absence of free hydrogen atom for bonding, so they cannot form any hydrogen bonds. And the order of boiling point will be higher in primary, a little bit lower in secondary, and least lower in tertiary. So let's move forward. So the next one is preparation of amines. So this is a chain reaction. We have to start with the ethyl iodide and ammonia here. Ethyl iodide and ammonia. So we will get our ethyl amine, one node amine, and by with the side product or byproduct of hydrogen iodide. So H from this molecule and I from this molecule will make hydrogen iodide, and our first node amine we will get here after the reaction. So we will have to use this product as a reactant in the second step, and the first reactant from the first step same, and again the I and the H will continue to make hydrogen iodide, and we will get our two node amine. And again we have to use this product as a reactant in the third step with the same reactant from the previous step, and In this step, the last hydrogen will also replaced by this ethyl group here, and we will get our 3-node amine with the formation of hydrogen halide. So let's talk about the reaction of amines. So this is a very simple reaction, carboxylic acid and amine. So we will get an amide and a water molecule. This reaction is also called condensation reaction because we get emanating an water molecule from here, OH and H, to H2O, and the rest one will called amide. Okay, amides. So amides, uh, an organic compound characterized by presence of carbonyl functional group. I mean C bond, double bond O, bonded to a nitrogen atom. Like here we have, this is N nitrogen and connected to a carbon double bond O, and we have to look at these two, C and N and O. This will make amide. We don't have to worry about the side groups. They may be H or alkyl groups or aromatic compounds, and on the other side also. So basically we have three types of amides also, primary, secondary or tertiary. So let's talk about their naming system. Their naming system is pretty much easy. Like we have to replace the ending name of the acid, uh, like endings of the acid, OIC acid or IC acid. Like we have carboxylic acid or any acid. So we have to replace it by the word amide. And also the carbonyl carbon is given a location number 1. So we have to count from there at that place from which the carbonyl carbon C double bond O carbon will get number 1, and rest of the countings to the other side of the chain. So for naming of secondary amines, uh, we have to use an N, uppercase N, uh, to designate that the alkyl group is on the nitrogen atom. Like here in this example, this is our amide group, C double bond O and N, and here we have a methyl group. On the other hand, we have a ethyl group, but we have to count from here 1 2 3, so propane, and this will be called the alkyl group because this is the longest chain. So N for the methyl, here capital N, methyl propane, and the we have to replace the ending with amide, so we have to put here amide and methyl propane amide. So tertiary amides named in the same way like we named the secondary amides, but we have to put one more n's, like here in this example N dimethyl propanamide, because we have here two alkyl groups. First one is this methyl and second one is methyl, so N dimethyl propanamide. Okay, let's move forward to the physical properties of amides. So in general, they can form hydrogen bonds, but not the tertiary amides. Melting points are higher in primary amides than secondary and the least in tertiary. Primary will have the higher, then secondary and the least tertiary, and they can form hydrogen bonds with water. And the lower amides, like 1 to 5 carbon atoms, are a little bit soluble in water. Okay, so let's move forward. Preparation of amides. So as you can see, here are three reactions. uh, Nitriles can be converted to amides, and carboxylic acid can be converted to amides by using DCC and activating agent, and the last one is direct conversion of carboxylic acid to an amide by the reaction with an amine. So this is the most important reaction here. So we will start with carboxylic acid and an amine, um, and this reaction will take an intermediate product formed called ammonium carboxylate salt, and the last we will get amide and water. Okay, so next we have reaction of amides. So here we have only one reaction. We have at first amide here, and the reaction is with water, so we will get our carboxylic acid and amine. So this reaction is also called hydrolysis reaction, as we react in the amide with the water. Okay, so uses. um, Uses like for amines, aromatic amines mainly used as a starting product for azo-dyes in making artificial fibers, in the production of detergents. And amides. Amides also have many uses, like in daily life or in industry, like ethanamide and dimethyl formoramide, which are used as solvents. And the nylons. Urea is used as a mainly in first fertilizers, in animal feed, in manufacturing of polymers and resins, and making plastic, and many different things. Okay, so let's move toward their molecular model. There's a little bit difference in both. Here in amine, we have N nitrogen attached to any H atoms or alkyl groups, representing by R here. And in the amide one, we have here C directly bonded to N, and C will also have a double bond with the oxygen atom. So this will be called amide group. Okay, everyone, thank you very much. Sorry for any interruptions. I hope you will like this and will understand this. I also have some handouts for my class fellows, so I will email it to my teacher, and you guys will get it from there. Thank you very much.